Before we get to examples, I want to explain some of the major characteristics of an ellipse that you'll need to know. We've got two pictures here. As you can see, this one's mostly a horizontal ellipse. The longer part's going horizontally. This one, the longer part is going vertically. So I might refer to a horizontal ellipse or a vertical ellipse, and that's what I mean. So this one I would be referring to as horizontal. This one I would be referring to as vertical. All right, so from there, we have a bunch of different characteristics. Now, along the horizontal ellipse, you'll notice that we have this term major axis. The major axis is going to be the axis that goes right through the middle of the longer part of the ellipse. And so in this case, the major axis is the x. Here, the major axis is the y-axis. The opposite is the minor. That's the part that goes through the shorter piece. Now, we talked about in the last video that the longer points on the outside are the vertices, and you might call those the major vertices, and then you also have here the minor vertices. So notice that these points, we have A0, we have negative A0, we have 0B, we have 0, negative B. What this basically means is that A is going to refer to, that's going to always be on the major axis, something to do with A, and then we'll always refer to B as being the one along the minor axis, so the shorter part of that. Now, the ones that are the longer are the only ones that are really considered vertices, but I'll sometimes refer to these as minor vertices. The only other letter that we'll notice here is we've got C. C refers to the foci. So when we're talking the foci, we're going to be using the variable c. Now down below here we have all the equations that are going to be really important for us as we do find things with ellipses. First of all, there's this, the standard equations. Here's one of them, here's another one. It depends on which one we're talking about. So notice that A is underneath x for this one, A is underneath y for this one. When you use this form of the equation, that means that this is mainly, the A is on the vertical portion, so this is going to be a vertical ellipse. This one's going to be a horizontal ellipse because the A is under the x. That's the longer side in this case. So we're going to use this to graph equations. We're going to find out these pieces from equations. But then this other thing we have here is the Pythagorean relation. And this one's like the Pythagorean theorem, although you notice that the A's, B's, and C's are mixed around a little bit. And that's just because of the characteristics inside an ellipse. So interesting that it has this relationship, but there is a right triangle, and the hypotenuse ends up being exactly A if we have B and C. So that's kind of an interesting relationship. There's a little more to it than what you might just think, oh yeah, it's just the Pythagorean theorem, but really it's kind of a special relationship in this case. Now all of these equations assume that we're at 0, 0, so if we're not at 0, 0, then we will adjust it a little bit, and you'll see that through the examples. We'll have one or two examples the rest of this lesson where it's not at 0, 0.